Hi, welcome to the bench. I'm trying to do, with my crappy English, a tutorial about things that are getting hot, like this heatsink for example. This is a 100 watt LED that's lit up and the heatsink is getting hot. That's obvious. But when you want to cool the heatsink down, you have to turn on the ventilator. The plus is going to the positive from my 12 volt and the minus is broken here. I will turn that back together and now the ventilator is turning on. Well, that's a quite simple schematic about what I just showed you. This is the motor of the ventilator and these are my two leads that are broken, and when you touch them together the lead will turn on the motor. But this is a 12 volt motor and it's getting 12 volt right now, so the motor is turning at 100% and that makes a lot of noise. So if you want to slow the motor down, you can turn back the voltage of the power supply . That's better. But how can we turn down the 12 volt on a 12 volt battery? Well, you can add a Mosfet, like here. So now we have this schematic. So instead of this switch, I've added a Mosfet, like here. This is the Mosfet. And this lead is not connected yet. So here it is, the Mosfet. The motor is not turning and the Mosfet has a loose wire. Now you have to add a little voltage to that wire to turn the motor on. You can even do it with your finger, the voltage of my body. Okay, here we go. Motor is on now. When I want to turn it off, I'll just touch the ground and the loose lead. The motor is turning off. First I let go the lead and then the ground and the motor stays off. That's the way a Mosfet works. So if we add a voltage divider to that lead that brings a little voltage to that lead, then we can regulate the power of the motor with 12 volts. Nice! Well, a voltage divider. It can be a 20k potentiometer. So this is what I did. Here's the Mosfet. Here was the loose lead of the Mosfet and here is a potentiometer. The first lead is going to the plus 12 volts, the second lead is going to the ground and the adjustable lead is going to the Mosfet. That's what I did. Here's the Mosfet. Here's a positive lead that goes to the first one. The ground is going to this one. And the adjustable lead, the middle one, is going to the loose wire of the Mosfet. We have 12 volts. The motor is not turning. Now when I'm going to adjust the potentiometer, I can start the motor. And I can also slow it down. It slows down. Can you hear that? But how can we prevent that the motor is running too slow, so that the heatsink is heating up? Well, it should be nice that there is some component that will change this voltage divider. When it's heating up, the voltage divider is turning higher and the Mosfet will let the motor turn faster. Well, that's quite easy with a thermistor. This is one, a 10k thermistor in this case. And this is the symbol of a thermistor. How can we add that to our schematic? When the thermistor is heating up, the resistance of the thermistor is going down. When it's cooling down, the resistance goes up. So if we add that between the 12 volt and this lead, it will bring the voltage up when it's heating up. And it will bring this voltage down when it's cooling down. Well, here it is. The first lead is going to the plus 12 volts. And the second lead is going to this wire that runs the Mosfet. So it can change value of the voltage divider. Here's the ventilator. Let's add some heat with my fingers. When it's heating up, the voltage is going higher and the Mosfet will turn on the ventilator. Now let's cool it down with the same ventilator. There we go. Here I've pushed the thermistor right in the heatsink so that it can feel the heat and it can react when the heatsink is turning up. Let's put on the 100 watt LED. Let's see what happens. The LED is heating the heatsink up. There it is. The ventilator starts spinning, but the motor is spinning just the right speed to prevent that it's at 100% and to prevent that it's turning too low. So it's stabilizing the temperature of the heatsink now. Very nice, eh? Until the next time, bye.